solving a multi-step equation involving a single logarithm, problem type 1. Here we change our focus to equations that have logarithms in them to start. Let's take something like the log base 2 of 5x minus 7 is equal to 3. Now here, the opposite of when we were solving the exponential equation, in this equation, we can say that the solutions to this equation are exactly the same as the solutions of the equation of 2 raised to the power. Of each side. Right? Not only by substitution do we know that if these things are equal, these things also must be equal, but we know because logarithm is monotonic, that is, it's always increasing or always decreasing if you have a fractional base, that means that for any equation like this, there's going to be exactly one solution. And because there's going to be exactly one solution here, and there's going to be exactly one solution there, we can't have lost a solution or gained an extraneous one like you have to worry about with square roots. Next, 2 raised to the power of this logarithm. Well, this logarithm is asking us, what power do we raise 2 to in order to get 5x minus 7? And then we raise 2 to that power. So that means we're going to get out 5x minus 7. On the right-hand side, 2 raised to the third power is 8. Add 7 to both sides of the equation, and divide by 5 to get that x is 3. That's really all there is to these equations. It can get a little bit trickier. The setup can get a little bit uglier. It can take some work to get to this point. But once you have it at this point, the process is always going to be the same. Choose whatever base you have and raise both sides of the equation to that base. The exponent and the log are going to cancel each other out, leaving you with the argument on one side. On the other side, you can actually evaluate the exponent, and then you have a linear or perhaps a quadratic equation, and you are very familiar with how to solve those at this point.